Hi guys, good evening and thanks for joining. So next topic is network architecture diagram. So in the network architecture diagram, this is applicable to not only on the on-premise or data center side, even this is applicable to cloud side also. So whenever maybe startup company or maybe greenfield site. What is meant by greenfield site? It's a completely new startup company. There is no existing infrastructure. There is no existing environment at all existing. That is called greenfield site. This is applicable to entire IT and software industry also. What is meant by greenfield site? There is no infrastructure it is existing. From the scratch, everything we have to develop. That is one of the option, or that is one of the use case, or that is one of the practical scenario. In this similar way, for already existing architecture also, if you want to do any modification based on the SABSA and based on the TOGAF. So these are all the couple of security architecture frameworks or diagrams. So as per Cisco terminology, as per SABSA terminology, as per TOGAF terminology, most of the companies follow this design only. So this is the way how the architecture looks like, or how the devices where we have to deploy or where we have to install. That entire design, we can call it as a network architecture diagram. So this particular architecture diagram, whatever we are going to discuss, it is applicable to cloud also. Nothing but, so directly you are moving application from on-premise to cloud environment or else. So directly you are hosting all the applications in the cloud environment. There is no existing infrastructure. So everything I want to host everything in the cloud also. So those scenario also this architecture diagram is applicable. So this architecture diagram, whatever we are going to discuss, it is applicable to both on-premise and data center level, and it is applicable to cloud also. Okay. So how this one looks like, and where we have to deploy what type of network devices, and where we have to deploy endpoints, where we have to deploy servers, where we have to deploy routers, where we have to deploy switches, and where we have to deploy load balancer, firewall, everything. So that entire pictorial representation or picture or logical design is called as network architecture diagram. Okay. So let's go and start here. Network architecture diagram. It is a logical or pictorial representation or blueprint of where to deploy what type of devices in the diagrammatic way or architecture way is called as a network architecture diagram. So most of the organizations will follow this architecture diagram only. So couple of frameworks already defined, very, very popular framework for the architecture diagram side. Couple of frameworks for designing the architecture of the network is we have SABSA. It is one of the framework. In-depth analysis we are going to discuss under the GRC. And also we have TOGAF. Even we do have certifications also on this one. SABSA architecture diagram, TOGAF architecture diagram, even certification of personal growth or career as well. And also Cisco as well. Cisco also provided another framework. Okay. So now how that architecture looks like. Now I will design that one, or I will draw that one. So there are three different types of zones in this particular diagram. What are those zones are? So this is server LAN. So all these servers we have to put in our touch zone. So those servers, example, whatever servers we discussed part of our theoretical part from last 2 to 3 classes. Example, Active Directory. In the similar way, we discussed about domain controller. In the similar way, we discussed about DNS. In the similar way, we discussed about DHCP. We discussed about database server. We discussed about SMTP server. We discussed about file server. And even we discussed about EDR tool and so on. So I will change the name. So this is Active Directory, this is DC, and this is DNS. So this is DHCP, and this server is database, app or web server, file server. So SM tool or EDR tool and so on, all the servers. So main thing, one more I want to add it here, SMTP. That is also very important server. So all these servers we can call server LAN. For these servers, we have to assign the static IP. As I said, part of the DHCP, for servers and databases, we will assign the static IP. For all the end user machines, we can assign the DHCP. So this is server LAN. So example 10.10.0.0/16. So all these IP address ranges I can provide here. And also I'm providing the connectivity as well through LAN, local area network. So these servers will be in always trust zone. We should not expose to the public. So these are all the critical servers to the organization side. So trust zone is also called as internal zone. So as per network three-tier architecture diagram defined by 3 zones, that is by Cisco. So this is called as a trust zone or internal zone. So this firewall concept as well. So for these servers also, even Windows and Linux also will fall under. Because of the space issues, I'm not including everything. So whatever security providing to these servers, we can call it as a vulnerability management VM. Scanning of the servers and identifying the vulnerabilities. So and analyzing those vulnerabilities and fixing the vulnerabilities by contacting the server owner or asset owner is called as a vulnerability management. It's a part of infrastructure security, or even this is applicable to cloud instances as well. Okay. For that one, we can use couple of monitoring tools. It's like infra security, or maybe we can say vulnerability management or server security. So from here, I'm giving one of the connection to access switch. So access switch, whenever any end user is providing the request to any access, first always it will go to access switch. That one already we discussed part of our data link layer. So this is called distributed switch, DS. In the similar way, this is our core switch. In the similar way, we have L3 router. And this is CS. CS means core switch. This DS means distributed switch. So it's not a mandated distributed switch always we have to use, depending on the how much traffic is generating in the organization side. And this is NADS, NAPS. And also we have proxy or web gateway. So next one we have firewall, next generation firewall or firewall. And finally, this one we are giving to ISP router. And next one is internet public. So internet symbol is this one. So now I have to give the connection between all these. So this is in between access switch and core switch. Sorry, not access switch, core switch. This is a distributor switch. In the similar way, distributor and core. In the similar way, core switch and L3 router. Next one, NADS, NAPS. It's a part of network security solution. In the similar way, we have proxy. In the similar way, we have firewall. Our next generation firewall, we can call it as ISP router from whatever internet service provider we are using. That may be AT&T or Geo or BSNL or Vodafone or Orange Business Services or Col Telecom. And finally, internet. So, and we have one more zone. I am doing segregation that one. So this zone is called as DMZ or DMZ. Firewall can be deployed always in the DMZ zone. It is acting as a wall in between our trust and also untrust network. Okay. So that is about overall architecture diagram, guys. So this is servers and server LAN and where the endpoints are existing. When I say endpoints, end user machines like a laptop or MacBook or workstation or desktop. So where those machines are existing, it's a part of in between access switch and distributed switch. All the end user machines will sit under here. Maybe DevOps team or machine learning team or cloud computing team or Windows Server team or Linux, HR, legal, network administrator, application development, product development, mobile development, cybersecurity SOC, endpoint security, and so on. So example, he is a HR guy. Don't think actor means he is a threat actor attacker. Just for simply, I am giving this one. And this is another end user. And this is another end user. Okay, so maybe he is using HR laptop. So LT means laptop. And he is using MacBook. He's a developer example. And he is a, okay, so local IT team using desktop DT. Okay. So now all these are called as endpoints. So our end user. So for this one also we can assign one of the dedicated range of the IP address. That one we can call end user LAN. So already 10.10.0.0/16 we given here. Now LAN segmentation maybe we can give here for end user side 10.20.0.0/16. Nothing but 2 power 16. How many IP addresses are available? That many IP addresses we can assign to these endpoints. Now where non-critical servers will sit, non-critical will servers sit in the DMZ. It is not that much critical to the organization side. So it's a more than one, but I'm giving everything like a non-critical servers. So all these are non-critical servers. And even public DNS also can sit here. And private DNS can be sit here because of the trust zone. Private DNS we should not expose to the public. And also we have to deploy in parallel to firewall, web application firewall. It will prevent and block all WASP top 10 category of the attacks related to application layer as per WASP top 10. So this is WAF, web application firewall. In the similar way, to take care of the phishing email, we have to deploy email gateway or email security solution. SMTP server for sending the mails and receiving the mails, but it will not take care of the blocking of the phishing email. For that one, we have to use one of the dedicated phishing email gateway or phishing email security solution. So we have to deploy that one under the 1 second DMZ zone. So this email gateway or email security solution. So even we can deploy load balancer also. Load balancer is not part of us. So that is the reason I'm not keeping here. So couple of organizations, load balancer and firewall can be handled by a single person. Okay, it depends on the organization. If it is a small company, so load balancer and firewall can be handled by net combination of the security plus network engineer. But if it is a bigger organization at enterprise level, so network engineering team is different and the security team is different. In those scenarios, so load balancer, routers and switches can be handled by network engineers, and all the firewalls, proxy, NADS, NYAPS can be handled by network security. But if they don't have the budget and if they don't have sufficient resources, and finally what they will do, they will recruit a combination of both. So nothing but load balancer and also firewall can be handled by single person. It depends on the organization basically, but most of the cases, network engines are different and firewall team is different. And this one is internet, as I said, it's a public network. Then this one is ISP router. Because of this one only we are getting the internet. So this is about overall network architecture diagram. So now we can go and we can discuss now one by one. So as I said, all these are server LAN. So all these servers, Active Directory will take care of the directory of all the end users machines. And whenever any new person is onboarding, so Windows administrator or sys administrator, they can go and they can create one of the dedicated username, part of the domain, and also they will allocate one of the system to him. And whenever the end user, newly joined guy, so if he wants to access the our LAN or maybe wireless LAN or maybe through VPN, he has to provide his newly provided username and password. So once he's provided the username and password, domain control, it will validate his credentials. Finally, he can log into the our local area network. Okay. So DNS, you know already, it will convert domain name into IP address using different types of DNS records. And the DHCP server, it will allocate IP address automatically using Doro process by end user is connecting either through maybe LAN or maybe through Wi-Fi connectivity. On database server, it will maintain all the databases using structured query language, most of the cases. That may be SQL or PGSQL or Oracle or GridGain or Couchbase or MongoDB, depending on what type of database we purchased. And application server, it will take care of the internal hosting of the applications on top of the web server or app server. So, okay, all of our internal critical applications can be hosted on our internal web servers. And file server, it will taking care of the all the centralized file storage location. And we have couple of SIM tools and EDR tools can be deployed here itself. And also we have SMTP server to send and to receive the emails. Okay, and also even we have Windows servers and Linux servers. All the servers can be deployed here itself. So that is about overall server. These server from the security point of view, if we want to protect, what we have to do, we have to take care of the vulnerability management. And also we have to take care of so many things. Those things we can describe one by one. First one is server security. So in my terminology, this one I will call it infra security as well. So this is the first one. So under this one, what are the things we are going to implement? How to protect servers. Second one is vulnerability management, nothing but regular security updates, scanning of the servers and everything. We have separate topic on this one, vulnerability management. Coming back, how to protect a server. So there are different things we have to implement to protect a server. What are those different types of things we have to implement? You know already, it's a very basic one. Default passwords, strong or complex passwords we have to implement. So nothing but we should use length is not 8 nowadays. Previously we are using 8. Now it should be 12 to 16 characters of the length of the password. Okay, uppercase, lowercase, alpha, numeric number, special character. So all those things we have to use part of the strong or complex password. You know already. Okay, so one is uppercase and lowercase, numerical number, a special character. Next one is minimum length should be 12 to 16 characters, password length. Okay, so that is about password length side. And the second one is multi-factor authentication, MFA, more than one way of authentication, either authenticator like maybe Microsoft Authenticator or Google Authenticator, or maybe through OTP, or maybe through CAPTCHA, or maybe through security questions, or maybe through RSA token. There are different ways we can implement more than one way of authentication. Okay. So entering the password is single authentication. On top of that one, if you want to validate once again through biometric or maybe through token based authentication, or maybe through security question, or maybe through one-time password, or maybe through authenticator like a Microsoft or Google Authenticator. So or maybe through CAPTCHA, there are different ways we can authenticate. So that is called multi-factor authentication, more than one way of authentication. So we have to implement that one also. Next one, default username and password we should not use. Whenever username, whenever server we are purchasing, by default they will give either demo or else admin. Example, IBM servers, HP server, Microsoft servers, Unix servers. If you are purchasing those server, by default they will give demo. We have to change immediately to our convenient and based on the complexity wise. So default passwords we should not use. And consecutive password we should not repeat. So what is mean by this one? So example, maybe in the May month, I given username as a password at the rate of 123. June month, once again, I should not repeat password at the rate of 123. Once again, July month also, I should not repeat once again password at the rate of 123. So consecutive passwords, I should not keep it as it is. So, and I should not repeat it. So that is called, so consecutive password we should not use for the regular way. So every time we have to change the new password. Otherwise, attacker can guess the easily username and password using trial and error method. And 90 days once we have to change the password. Couple of companies, they are changing this one for 30 days also. Depend on organization to organization. What is the password policy they defined? Okay, so that is about password policies. This is one thing we have to implement on the server side. That is the way how we can protect the server. What is second point? So better I can keep all these at like a B. Otherwise you'll get confusion. This is C. This is D. And this is E. And this is A. All these are A point. Okay. So now what is second point here? A role-based access control, RBAC control we have to implement. So based on the role, for everyone, we should not give the same access in the server side. For everyone, we should not give the root account or sudo account to every user. For everyone, we are giving the same type of the access. We don't know who is doing what. Okay. So for example, everyone I am giving the administrator and with admin username and password. Whenever some of the unwantedly, maybe knowingly or unknowingly, or intentionally or unintentionally, maybe they added some of the data in the server, or maybe they deleted some of the data, or maybe they updated some of the data, or maybe they configured some of the data. So in that scenario, for traceability, it's very difficult for us. So that is the reason, according to what is the role he wants to access the server, why he wants to access the server, which role we have to provide, what type of services or what type of things he has to do is part of the server. According to their activities or enablement of the services part, whatever he wants to access, according to that one only we have to give the respective privilege or acts or grants or permission. So implementing all these things, we can call it as role-based access control, RBAC. Implement role-based access controls. So based on the user actions or tasks or roles. Okay. So example, we have user account, we have service account, we have admin account. It's a part of the Windows server. If it is Unix server, we have the user account, service account, so sudo account and root account. So it is depending on server to server. So that is the second point. Third one, what we have to implement on the server side, we have to implement CIS hardening benchmark. What is the CIS hardening benchmark? So it is for Center for Internet Security. This is an institutional organization. It is providing the couple of benchmark, couple of baselines. Those baselines we have to configure initially by the server team, so that whenever any attacker wants to hack the server, because of these implementations or because of these configurations, we can reduce the risk, or we can reduce the attack vector, we can reduce the hacking capability by the attacker. So that is the reason these baselines, whatever, or these compliances, whatever defined by CIS organization, we have to configure all those. As a security analyst, we no need to configure all those. These configurations can be done by respect to server owner or asset owner or business owner. Then what is our role part of the CIS benchmark? So how many are passed, how many are failed? We have to validate. Like if we have to do auditing kind of thing. Okay. So that is CIS benchmark. So these are all the initial security configurations or implementations. So next one is regular patch updates. So whatever libraries and packages are deployed on top of the server, so or maybe on top of the endpoints or database servers, so regularly we have to update those patches. So this can be done by obviously server team, and regularly vulnerability management patch updates or vulnerability scannings regularly or monthly once, run the vulnerability scans and patch those vulnerabilities. Patching cannot be done by us, but patching can be done by, so respect to server team. What we have to do, we have to run the, okay, so vulnerability management scans or vulnerability assessment scans, and we have to generate the report, and we have to share with the respect to server owner or maybe asset owner or business owner. Then they will do the patch updates related to security. And once they will confirm they patched or not, if they will patch, they will confirm back to us. And once again, we have to rerun whether all those patch updates completed or not. Okay. So based on our request and based on our confirmation, now once again, they will raise a change request and they will implement production environment. I'm going too much in depth. Don't worry. All these things we can discuss part of vulnerability management once again. Now, next one is implement antivirus agent or EDR agent in the server or solution otherwise directly. So if you are implementing antivirus or EDR agent on the server, whenever any server owner or maybe database owner or Windows owner or Linux owner, if they are downloading any malware category of the files, okay, so or maybe they are copying any malware category of the files. So this EDR agent or antivirus agent, it will block that malicious content of the files. So that is the importance of the antivirus or EDR. What is EDR? Endpoint detection response. It will prevent and block all malware category of the attacks. So that is about, so why we have to implement or why we have to install antivirus and EDR agent. In the similar way, implement DLP solution. So we have to implement DLP as well, data loss or data leak prevention. Whenever any server owner or whoever has the access to the server, if they're trying to leak the data, if they're trying to do data exfiltration or maybe data breach or data violation, not only from the internal employee, even the external attacker also, they are trying to compromise the server and they are copying of any data related to critical or non-critical. In that scenario, DLP solution can be block that activity. So that's why we have to implement DLP as well as a part of the server point of view. Next one, we have to encrypt the disk also. Encrypt the disk. Nothing but disk encryption. Whenever any damage it's happened to the server, if you want to make sure that that data should be protected, for that one we have to use one of the key to protect entire data. That is called data at the rest level of the encryption. So we have to implement that data at the rest level of the encryption. This is not only applicable to our Windows servers or Unix servers, even database servers also. File side we have to do encryption, and entire database side we have to encryption. Query side we have to do encryption. It depending on which type of server we are doing the encryption. So this is the one thing we have to implement. This encryption we can call it a data at the rest level of the encryption. So next one, what we have to do, we have to implement file integrity monitoring also. We have to implement FIM solution for this server. Whenever someone trying to uh, add or copy the file or download the file or upload the file or delete the file or change the file or change the configuration, so automatically this FIM solution, what it will do, it will throw an alert notification stating that one of the unauthorized user is trying to do some of the malicious activity. That may be internal employee or maybe external attacker also. Any of the cases it is possible. Finally, whatever logs are generated in the server, so that may be Windows server or Unix server or database server or DNS server or DHCP server, every log we have to integrate it to SIM tool. Okay, all the server logs should be integrated to SIM tool and create a rule for triggering the alert whenever any malicious activity it's happened. So that is the way how we can protect the server. These many controls we have to implement, guys. These many controls we have to implement to protect any of the server, irrespective of the whether it's a middleware server or database server, or maybe okay Windows server or Unix server, or maybe cloud server or virtual machine. So all these different types of security controls we have to implement. That too, we don't have guarantee whether really server can be protected or not. Okay. So, but anyways, to reduce at least risk cannot be eliminated 100%, but risk can be reduced. Okay. So that's why we are taking LIC policy and also health insurance policy, right? We don't know whenever what is going to happen to our life. So that is the reason with the third party insurance we are doing. So we are eliminating the risk for our life. Same way, we are reducing the risk by implementing all the security controls. So that is the way how we are protecting our server. Okay. So that is about overall under the server side, what we have to do along with this one dedicatedly, as said, vulnerability management. So regularly monthly ones. So it depends on the organization to organization also, whether we have to run monthly basis or quarterly basis. Weekly basis, we should not run the server scan. Okay. So it's better to run either monthly or quarterly only. Why? Because server can be accessed by multiple people. If we're running on the weekly basis, there are a lot of performance issues will occur. Maybe applications will be breakdown. So that is the reason it's better to run on monthly basis and identify the vulnerabilities and inform to respective server team, and they will do the patch updates. So that is about overall. Okay, so infrastructure security or server security. That is the only one portion we discussed part of network architecture diagram. Let's go and see remaining things. So this is over now. So next one is endpoints. So endpoints is nothing but all the internal stakeholders, all the employees in the organization, irrespective of the team. That may be HR team or legal team, or maybe network administrator or network team or NOC team or SOC team, or endpoint security team or network security, machine learning team, DevOps team, testers, developers, programmers, okay, product owners, everybody in the organization. So they will use endpoints. Endpoint is nothing but end user machine or host machine. Whatever security control, if you are implementing all these employees machines like a laptop or MacBook or workstation or desktop, those security controls or those security solutions, we can call it as endpoint security solutions or endpoint protection of the solutions. So nothing but here we have to provide the security. Those securities we can call it as endpoint security or endpoint protection. What are the different types of security solutions we can implement part of endpoint security or endpoint protection? We'll implement antivirus and EDR or XDR. We'll implement DLP, endpoint DLP. We'll implement HADS, HAPS. We'll implement file integrity monitoring, FIM. We'll implement data at rest encryption or endpoint encryption. And finally, in case organizations are providing mobile devices to each and every employee, even we have to take care of the mobile protection also. That is called MDM, mobile device management. So these are all the solutions will come under the endpoint security or endpoint protection. So second thing, as per network architecture diagram, endpoint security or endpoint protection. This is also called as EPP. EPP full form is endpoint protection. So what are the different types of, so first what is meant by endpoint? So already we discussed all these things. We are repeating once again. So endpoint is equivalent to end user machine or employee machine or asset or host machine. We can call it as endpoint. Now example of endpoints, what employee will use as an asset or what he will use for working purpose. So examples of endpoints are, so we will use either laptop or couple of companies will provide MacBook, couple of banking sector, healthcare sector, they will provide workstation or desktop. And even servers also we have to consider as endpoints, because servers also we have to take care of the DLP and also we have to take care of the malware scanning and also file integrity monitoring and everything. So now, what are the different types of security solutions to protect all these endpoints? For protecting of endpoints or host machines using different types of solutions or tools called as endpoint protection or endpoint security. So take example of your laptop itself, company provided laptop. So what are the different type solutions we have to provide? So examples of the endpoint security solutions are, so as I said already, antivirus or EDR or XDR, we have to implement, and endpoint DLP we have to implement. In the similar way, HADS, HAPS capability we have to implement. In the similar way, we have to implement data at rest encryption, that is called endpoint encryption or server encryption or database encryption. And we have to implement file integrity monitoring, FIM solution. And even as I said, in case companies providing, very rare companies will provide mobile device to employees. For those companies, whatever mobiles are providing to employees, we have to protect mobile devices as well. That is called MDM, mobile device management. So all these are endpoint security solutions. So now go back to our diagram. Whenever end user is trying to access any google.com or facebook.com. So this is like internal zone. This zone is called as internal zone, internal to organization. That's why it is called internal. This is also called a very trust. And this one is called DMZ zone or DMZ, demilitarized zone or so DMZ zone, because in USA or North America, Z they will call it G. That's the reason DMG, DMZ or DMZ. Nothing but full form is demilitarized zone. Interior question, what is meant by DMZ? So finally, this last zone is called as, I will reduce the font size. Yeah. So this one is called as untrust or external, or public, or internet. We should not trust. So all these attackers will sit here. Where the attackers will be sit here, or where the public will sit here, they will sit here. Public is for legitimate purpose, and the attackers also will be in the public place. Okay. So now when the end user, I know this is font size is very less. Yeah. Yeah. Now you can see. So all these end users, now end user wants to, so he's sitting in the organization. If he wants to access any external public website, where the external public website it will sit in the untrust or external or public or internet. Example, they want to access facebook.com, or maybe they want to access google.com, or maybe they want to access youtube.com. All these are public websites to all these employees. Now whenever the end user is, they are trying to access all these publicly facing the websites, how the traffic it will go. So the traffic it will go to first DNS, or first it will go to access switch. From the endpoint machine, from access switch it will go to DNS. For resolution side, what type of the website or domain he wants to access, and once again it will come back, and it will so travel the traffic or packet via distributor switch, core switch, router, NADS, NAPS, a proxy. By the by DNS, it will validate whether the domain is whitelisted domain or blacklisted domain. In the similar way, IDS, IPS also will validate. Proxy also it will validate. Firewall also it will validate whether the domain and the application or website, whenever the end user is trying to access, based on our company policies or based on our business requirement, it is accepted website or rejected website or blocked website. So all those verifications also can be done by different types of tools. Basically, one is DNS, it can do, that is called DNS filtering, and proxy can do, that is called, so once again, website filtering or URL filtering, and even firewall also can do, that is called as URL filtering or DNS filtering. And finally, it will go to firewall. Then firewall, it will go to ISP router, and ISP router, it will go to internet, and finally, you can access facebook.com. So the traffic is going now from internal to external, or trust zone to untrust zone. The traffic is going away from internal to external, or trust to untrust zone. This traffic is called as outbound traffic. For example, you are making one of the call to other people, that is called outgoing call. But you are receiving one of the call from others, that is called an incoming call. Same way, the traffic is going away from trust or internal zone to untrust or external or public or internet. That one we can call it as outbound traffic or outgoing traffic. Okay, what is outbound traffic? This is also called outgoing traffic. So the traffic is going away from internal or trust to external or public or untrust or internet, is called as outbound traffic or outgoing traffic. Better you can use outbound as a technical terminology. Okay. So that is about outbound. In this similar way, opposite to outbound traffic is inbound traffic or incoming traffic. So how we can define this one? So now go back to our diagram. So this is our web server. Okay. So on top of this web server, so take the entire architecture diagram is part of our Accenture or Accenture, whatever you'll call it as. So this is Accenture website or Accenture network architecture diagram. Now I'm the public. I'm not working in Accenture or Accenture, whatever it may be. Now I want to apply one of the job in the accenturecareers.com. Now Accenture website where it can be hosted, it can be hosted on top of the web server. Where the web server it is hosted in the trust zone. So accenture.com careers website is available on top of this one. So www.accenture.com/careers. So this is the website name where I can go and I can apply cybersecurity vacancies. Now I am the public. Now where I am sitting here, as per network architecture diagram, I will sit here. Now in my laptop or in my mobile, I will open Accenture website, part of the careers. Then the traffic will go from external to internal. So how the traffic will go now? It will go, first it will go to my laptop to internet. From internet, it will go to ISP router, then ISP router to firewall, and firewall it will validate. So whether this particular request is coming from legitimate IP or illegitimate IP, malicious IP or non-malicious IP. All those things also can be validated. That is called deep packet inspection or stateful inspection, where the packet is coming from. Okay, that is firewall concept. Now the traffic will go to proxy and proxy to NADS and APS, then router, core switch, distributor switch, then access switch, then it will go to so DNS of the okay. So respect to website, from DNS it will read to web server. So that is the way how the traffic will go. So this traffic is called as the traffic is coming from external to internal, or untrust to trust, or internet to internal, or external to internal, or public to internal, or public to private, is called as inbound traffic or incoming traffic. Is the opposite basically. The traffic is coming from external or untrust or internet or public to internal or trust or private, is called as inbound traffic or incoming traffic. So that is about both outbound traffic and also inbound traffic. Now if you are summing together, this combination of both is called as net flow data. What is net flow data? Combination of both inbound traffic and outbound traffic, or incoming traffic or outgoing traffic, is called as net flow data. Net, what is meant by net? Nothing but sum. Okay. So net flow data. So this net flow data terminology is given by Cisco company. So if you are using Cisco routers and Cisco switches, we can call it as net flow data. Okay. So I will put note that one. Note. So net flow terminology provided by Cisco. So if you are using Cisco routers and Cisco switches, if you are using Cisco routers and switches in our organization, is called as net flow data. Nothing but overall inbound traffic and outbound traffic. So this is Cisco. In this similar, this one already we discussed. I'm repeating once again, whoever is attended. So cybersecurity definitions. If you're using HP routers and switches in our organization, we can call it as the S flow data or YS flow data. So if you are using Juniper routers and Juniper switches, we can call J flow data. In the similar way, if you are using Avaya routers and switches, we can call it net flow data once again. If you are using IBM routers and switches, Same thing, net flow data. Even if you're doing HP or Hawaii, we can call it as net flow data. So that is about overall. Net flow is nothing but overall traffic. Entire traffic of the organization is called as net flow data. That is also another term definition. Okay. Now go back to our diagram. So access switch, it is the first entry point whenever end user is accessing any website or any request. Then from there, it will go to distributor and core switch. It will maintain the entire traffic of the organization, and router, it will route the traffic from source to destination through packet way. Okay. So our source to destination using IP packets, and NADS, NAPS, proxy, and firewall. These three solutions from the perimeter side, if you want to protect on the network side attacks, we can call it as network security or perimeter security. In the perimeter side, if you want to protect attacks from the hackers or intruders or attackers, we have to deploy three different types of solutions. Those solutions are network IDS, network IPS, or proxy or web gateway or next generation firewall. So these solutions we can call it as network security solutions or perimeter security solutions. Okay. These three also we can call it as network three-tier architecture. It's a Cisco terminology once again. So next one, network security or perimeter security. If you want to protect attacks from network or perimeter side, we can use couple of solutions. To safeguard our network or organization. Is called as network security solutions. So those solutions are, first one is next generation firewall. Second one, NADS, NAPS, network intrusion detection system, a network intrusion prevention system. Third one is proxy, that may forward proxy or reverse proxy. This is also called as secure web gateway or app gateway. Okay, so these three is also called as network three-tier architecture diagram or network three-tier architecture components. Entire question this one. Network three-tier architecture. So that is about network security solution. And go back to our network architecture diagram. And whenever any phishing emails are receiving by respect to end users, that may be spear phishing or whaling, or maybe through malicious URL link, or maybe malicious malware attachment, or maybe through spam emails. So our email gateway, it will act as a bridge or gateway between external phishing email attackers to our internal SMTP server or internal end users. Whenever we are referring gateway, think like a bridge or broker or intermediate device. Now this email gateway, it will act as a broker or intermediate device or tool or bridge or gateway between where and where, between phishing email attackers. Where phishing email attackers will sit, obviously phishing email attackers can be sit by here. So these are all attackers. So they will send the phishing email. Now, whenever they are sending the phishing email, it will come to internet to ISP router, firewall, then firewall, it will forward to email gateway. Now, email gateway or email security solution, what it will do, what is the domain, what is the IP address? In that email, is there any malicious URL link? Is there any malware attachment? What is the body of the content of the payload? That is called a header analyzer. Everything it validate. So then according to the malicious content it is existing, either it will do quarantine or maybe it will allow or maybe it will block the activity. So in case it is legitimate email, it will forward to proxy, proxy to NADS, NAPS, then router, and core switch, then access switch, distributed switch, then finally it will go to SMTP server. SMTP server, it will reroute to our end users, who is the recipients in our organization. That is the way how the email gateway inbound and outbound. Same way, our internal employee, they want to send one of the email to external world. So these are all our internal employees. Whenever they are drafting an email, so and they are sending the email, it will go to access switch, then it will go to SMTP server to distributor switch, core switch, router, NADS, NAPS, proxy, firewall, ISP router, internet, and whatever external recipient email address it is available, it will route to external public or recipient. So this is the way how the outbound email it will go. So that is about overall phishing email or email security or email gateway or email security solutions. Next one, email security. For this one, we can implement our email gateway. For phishing email protection, we will deploy or we will implement email security solution or email gateway. So email gateway, it will act as a gateway or bridge between, then say broker or intermediate device. For understanding purpose, I used broker. Email gateway, it will act as a gateway or bridge between external phishing email attackers to our internal users. So couple of, okay, we have solutions are available in the market or tools are available in the market. For example, Proofpoint, Mimecast, Ironport, Office 365 phishing email defender. So these are all very famous tools. Okay. So that is about email security. Now coming to application security, see we have WAF. WAF is a web application firewall. So what is the difference between next generation firewall and web application firewall? So as per voice layer 1 to 7, so mainly layer number 3 and layer number 4 firewall will work. But nowadays next generation firewall capability, it is extended up to application side also. But it will not do full-fledged capability 100%. Whatever dedicated web application firewall is doing. Okay, web application firewall dedicatedly, it will take care of the layer number 7 attacks as per OSI reference model. What is layer number 7 as per OSI reference model or OSI model? It is application layer. Nothing but it will prevent and block all WASP top 10 or SANS top 25 attacks. That is application security side. Not only that one, even we have to implement part of the SDLC life cycle, software development life cycle. Each and every phase of the software development life cycle, we have to implement security controls. We have to do scanning and penetration testing, threat modeling, and code scanning, third-party software scanning, and everything. That is called application security. Same thing is applicable to product security. Same thing is applicable to mobile security. Same thing is applicable to OT or IoT or IIoT security as well. All these are products oriented. Okay, next one is application security. I will keep all application or product or mobile or OT, operational technology, IoT, Internet of Things, IIoT, industrial Internet of Things like a SCADA, PLC, civil, electrical, mechanical, all those like a Honeywell, aviation part, Robert Bosch, next one, Quest Global. So these are the companies dedicatedly, they are working on the electrical, civil, mechanical, SCADA, PLC oriented, industrial control system, basically in simple words, if you want to say. So security here. So here we have to implement web application firewall. If I are for mobile security related, so firewall we have to implement part of the OASP top 10. And second one, secure SDLC lifecycle. I cannot show that one part of the diagram. I will explain at the time of the application security concepts. So secure SDLC lifecycle meaning SDLC lifecycle is normal developers, testers, DevOps team, TechOps team, site reliability engineer team, product owners, development master, scrum master, as well as scrum team, they will take care. But we are not part of the SDLC lifecycle. We are part of secure SDLC lifecycle. Whatever product owner, development master, scrum master, part of the Agile and Scrum team, and also requirement phase, design phase, development phase, testing phase, operational phase. Each and every phase, we have to take care of the appropriate security, vulnerability scanning, or code scanning, or third-party software scanning, or threat modeling, or penetration testing. Finally, after completing everything, once we will sign off, then only it will go to public or customers. And we can see in the news channel stating that Apple company is released a new product, Apple 16. Please go and utilize it, or please go and purchase it. Okay, WhatsApp application is a new feature, so please go and utilize it. Facebook is released new feature, please go and utilize it. This is the way, after completing all the testing from the security side also, they will release to the public. So this is the way how the entire secure SDLC lifecycle security you have to take care. That is called application security. Same thing is applicable to product and mobile as well. So next one, as per the, okay, so these information security, this is overall organization network architecture diagram. So to take care of the business objectives, business goals, and also auditing, and also governance, risk, and compliances, what type of compliances we have to follow based on our business, whether we have to follow PCI DSS or HIPAA or GDPR or SOX or SOC 1, SOC 2, it depends. So that is called information security, like auditing or risk assessment and risk analysis. That is information security. It's overall organization security. Information security, overall organization security. Okay, so under this one, we have to take care of the GRC, governance, risk and compliances, risk assessment and auditing, and compliance validation. So then we have to take care of the maybe business continuity planning and disaster recovery. Third one is incident management. Okay, so all those will fall under information security. So that one I cannot show in the diagram. You know about, right? Overall business, how we are getting, how the reputation of the company can be prevented from the attackers or hackers. So under auditing, yes, we can do. Under the endpoint side, sufficient controls are available. On the server side, sufficient controls are available. On the network side, sufficient controls are available. That auditing we can do, that is internal audit. And once again, based on the business wise also, we have to do either ISO 27001 or whatever business we are doing. According to that one, we have to do certifications as well. Once we will complete internal audit, external audit can be completed by third party vendors like Deloitte or KPMG or PwC or Ernst & Young or NCC Corporation and so on. That is information security. Now, one more security we do have, physical security. Physical security meaning here, where we have to deploy CCTV cameras and where we have to deploy door controls or access controls, and also access card we have to provide to the employees. So that is part of the physical security. Next one is we have cloud security. Whatever we deployed in the on-premise, same thing we have to deploy in the cloud as it is, using cloud services provider default services or maybe third party. So same as it is, we have to implement cloud also. That is called cloud security. To take care of the 24/7 into 365 days, security monitoring, all the servers, all the databases, all the applications, all the endpoints, all the network, all the, okay, so emails, entire organization is called as cyber security using SIM tool. See the simple network architecture diagram, how much information it is providing to us. Lot of information is providing to us. Entire so many security domains, information it is providing to us. But it looks very simple for us, but it has a lot of information. It will cover so many domains, so many security technologies. Okay. So next one, cloud security. Whatever on-premise controls we deployed, same way we have to deploy security controls in the cloud service provider as well. In the cloud also, in the cloud as well, is called as cloud security. Okay. Physical security anyways, that is physical point of view, like access control or CCTV cameras or carbon dioxide cylinders. So access cards under tailgating we should not allow. All this can be part of the physical security. I'm not keeping that one here. And cyber security, to monitor or to protect or to safeguard entire organizations data or information or endpoints or servers or databases or network or cloud or applications extra 24 bar, nothing but without missing 1 second also, 24 bar 7 bar 365 days is called as cyber security using SIM tool. Okay. It is unified console. All the logs can be integrated to that tool, and we will take care of the from single console everything. So that is called cyber security SOC operations. Okay. Yeah, DMZ zone. What are the different types of zones are available? Types of zones. One is internal or trust. Second one is DMZ or DMZ. Third one is untrust or public or external or internet. Okay. So as per Cisco terminology, this one. Cisco's provided these three terminologies for Cisco ASA firewall. So now trust zone. So Cisco already provided some of this core also. Okay. So whenever you are referring the firewall concept or internal or DMZ or internet zone, please consider your individual house. Your individual house, not apartment. So your individual house is situated or located in the dedicated space, and in front of your house, you are making a fencing, or maybe you are making a gate, or maybe you are making a wall. So after in front of your house, public street or cement road or tar road, anybody can use it. It's like a public. So now internal zone is like your home, and so firewall it will like your gate or your fencing or your wall. So in the similar way, external road, street or tar road or cement road, whatever in front of your house, that is like a public. Okay. Now, if you want to prevent from the thieves or robbers from any, okay, so breaching of the money or taking of the furniture and so on, we have to protect our house. So as per the security point of view, always we have to protect our furniture, always have to protect our gold, always have to protect our money. So that is the security point of view. Always we have to safeguard everything from our home side. So that is the why we have to give 100 out of 100 secure score. Okay. Nobody should not enter. For that one, we can implement maybe CCTV cameras. Maybe we can implement a security guard in front of the house. Maybe we can implement a dog, so that whenever any thief or robber will come, it will bark it. Or we have to implement alarms whenever they are trying to enter into our house. So this is the way we can protect our house. So that's why security score is 100% 100. We should not allow anybody or unknown people entering to our home and take whatever they want. Okay. So now DMZ or DMZ like a 50-50 in between wall in between, sorry, your house and also public street. Okay. So it's like a 50-50 in between. And finally, untrust. So cement road is not my road. I did not put it for my own. So tar road is not my own. It's for public. Anybody can use it. So that's why score may be okay 0. So these are all the 3 different types of, okay, zones can be provided by, yeah, sorry guys. So these are all the 3 different type zones provided by as per Cisco company terminology. That too Cisco AC firewall, but we can use it for us also. Next one is DMZ zone or DMZ zone. Full form is demilitarized zone. So it came from military terminology. It came from military. So how the military team, they can, even navy or army or military, so they can, okay, so stay in between boundary in between 2 countries or maybe in the oceans. So finally they will safeguard our country. So it will act as a now in between, okay, so one country to another country. Same way, demilitarized zone can act as a, so in between trust zone and untrust zone. That is called as DMZ zone. Okay, for example, so whatever army or military team, they are sitting in front of our India border and also Pakistan border. So those people will act as now DMZ zone. And whenever any, so other people, they are entering into our border, they will try to protect them. Okay, so that boundary we can call DMZ zone or DMZ zone. It will act as a boundary between trust zone and untrust zone. Trust zone is India, untrust zone is Pakistan. Example, sorry to say, sorry to bring country names here. Apologies. Okay, so it will act as a boundary between trust and untrust zone is called as DMZ and DMZ zone. Okay, so it's like a boundary in between 2 different types of zones is called as like a middle. So I think that's all, guys. I covered everything. Yeah, I have to cover one more topic that I will cover part of the application 3-tier architecture under the application security. Okay, I hope I covered everything part of the network architecture diagram. Yeah, okay. So that's it, guys. Do you have any questions? Yeah, same thing. I want to clarify one more thing. Whatever we deployed in the on-premise or data center, same as it is, we have to deploy in the cloud also. Whenever any application is migrating from on-premise to cloud environment, or else, even directly, if I want to host my rkcybertechnologies.com application in the cloud instead of the physical server or physical location, example, I can go and I can take, okay, so license, I mean, respect to services, and I can go and I can deploy my websites or maybe application in the directly. So Amazon Web Services. So there also I have to implement all these sufficient controls, same as it is. There is no difference at all. Maybe terminology is different. And one more thing, WAF will come first in the cloud security architecture diagram. So WAP will come first here, but in the on-premise, it will come as a parallel. And the load balancer, maybe you can ask, load balancer, we can keep behind firewall. We can keep it here. It will do the balancing of the load. It will do SSL offloading. Because it's not a security device, that's why I did not put it, I did not keep it. Okay. So that's all, guys. Do you have any questions in this one? Any question? Yeah, by the by, whenever I'm going to discuss about firewall topic, network security topic, or endpoint security topic, you have to keep always this architecture diagram in your mind or in your brain. Because sometimes I will say how the traffic will go here and there, how the traffic will come, what is the inbound traffic and what is the outbound traffic. You should remember always this architecture diagram in your mind. Otherwise, couple of concepts you will not understand properly. Once again, I have to come here and I have to explain everything from the scratch. Okay. So that's it, guys. Do you have any questions?
So I have one like on the endpoint user, if he's opening something like a not legitimate, like a let's say mega upload or something site. So where do you configure that? What tool you will be configure that one?
Yeah, it's a good question. Yeah, basically nowadays, whatever EDR and XDR we are purchasing, by default, we have app control and web control policy. So web control and app control policy meaning here. So web control meaning here, which websites we have to allow and which websites we have to block. App control meaning which application category of the applications we can allow and which application category of the applications we can block. Okay, so now whatever website you are referring, whether first of all, whether using that website or using that application, are we doing business or not? First, we have to identify that one. How we can get that information? So by contacting the internal stakeholders. So for example, what DevOps team they are regularly using for websites? Access purpose. In the similar way, HR team regularly what type of websites or applications they are trying to access. In the similar way, other teams as well, other internal stakeholders. After gathering all these requirements, based on our business requirement side, which websites or which applications we have to allow, and which websites and which applications we have to block. In the EDR and XDR, that capability is existing nowadays. Otherwise, we can do under the DNS filtering option also. Even we can do under the proxy under we have URL filtering or bright cloud URL filtering or content filtering or web filtering option is available. Even in case these three tools are missed out, EDR, DNS, and also proxy is missed out. And finally, even we have firewall also. In the firewall also, we can go and we can create a policy related to URL filtering or web filtering or so content filtering or bright cloud URL filtering. There are 4 tools are there to take care of this policy. Is it clear?
Yep.
Yeah. So that in-depth analysis I'll explain later. Don't worry. Yeah. Is there any other questions?
Yeah, hi, okay, sir.
Yeah, please.
Regarding that N-app,
Nmap I will explain tomorrow. Actually, I thought to complete because you should understand that is a very important. Forget about how many days it will take the class. So tomorrow I will explain Nmap tomorrow morning.
yeah, okay, thank you.
Welcome. Any other? Okay, guys. Then thank you so much. See you tomorrow at 7:30 a.m. IST. Same link you can join. Already I shared up to October 1st. So you can join with the same link. Okay, guys. Thank you so much. Have a nice day and a good night.
Yeah, thank you.